Hello, welcome to the MotionWall online video presentation. This presentation will discuss the actual on-site testing for this dissertation project for the University of Liverpool for a master's project in advanced computer science. The testing site was hosted thanks to Modular Cubed and JP Concrete. After giving a brief tour, we were given several locations for the device to be placed against. After careful evaluation, we decided to select this section. This section was chosen as it was a replication of a wall which could be mounted against. Once selected, each sensor was carefully planned out in its placement and was stuck down using multiple forms of adhesive. Adhesive choice was important as certain sensors were reaction-based, such as acceleration and vibration. All these sensors were labelled so the digger and the testing bed would know exactly where to hit. Once specified, the device was ready. The device automatically connected to my personal iPhone's hotspot to receive and disperse data. A total of 35 minutes was used for the device to record average readings. This was especially important as there were extreme harsh weather conditions such as wind speed affecting, as you can hear in this video recording. These average values would help with the predictive learning which will be discussed later on. Once the 35 minutes were up, a digger was called to simulate displacement against the sensor. The digger did hit against next to and above the sensor to try and trigger multiple different events. Whilst the digger was projecting these readings, the laptop did simulate an external member previewing this information. A 5-minute rest period did occur after this to ensure that no sensory damage was done against these harsh weather conditions. Once confirmed, the digger went in against the next block moving onwards. This form of testing resulted in the most impact, resulting in 11 forms of vibration within the 10-second interval and mass amount of acceleration. After the 2-minute stress test was over, the moisture sensor was put into question. As no moisture readings were read, some assistance was given. After all values were read and confirmed, the predictive analysis function did start running. This predicted the next day's forecast within the same time period between 12 and 2 p.m. This analysis tool used random forest regression and worked within 10-minute intervals, as the data used was not long enough for daily tracking. The entire system can be viewed on a front-end web application using React. All the data is saved using DynamoDB, which is a NoSQL-like format and uses a RESTful API using serverless functionality. The sensory values that we were recording were vibration, moisture, acceleration in X, Y, and Z, and also temperature and humidity. One of the major keys for the MotionWall project was related towards notification if any value was measured to be higher than expected. We can do this by a test. On the right hand side is the actual Raspberry Pi, the left the email of a user, and here is the front-end web application. If we change our temperature trigger value to be 22 degrees Celsius and we start running the Pi, we see the average readings to be 27 degrees Celsius. This will then trigger the Pi to send a notification to the user informing them of this change, requiring someone to come there for assistance. The predictive analysis, even though only having a single run, did identify that throughout the day various changes of acceleration, vibration, and temperature were read, identifying key areas and timeframes that builders should be required to view and assess the data. All in all, the project was a success. Within the given time frame, we created a budget-friendly structural health monitoring system which was able to capture various forms of displacement against a wall. We were able to record on-site readings within a construction site while also having large amounts of displacement and harsh weather conditions for the time. Not only this, but we created a front-end application and also an entire cloud-based format for the data to be stored and managed while also including a RESTful API. Thank you for watching the online video presentation for the MotionWall Dissertation project by Eamon Magdoubi. Thank you.